So this is the tutorial question. Let's start from the first one. Okay, let's have some recap. Okay, let's have some recap on the slides that we have gone through, right? So we have gone through the static equilibrium. So later we'll have the questions about static equilibrium. Then we have also go through on how to find the resultant forces by calculating the total horizontal component, vertical component, then the magnitude and also the direction. Okay, and we have go through the problems that involve more than 2 forces. We have up to 4, and how we actually calculating the horizontal and vertical components, and also find the magnitude and also the angle. Okay, so this is what we have gone through. Right, so now let's continue with the tutorial question 1. Okay, can I have any students unmute the mic and let me know that you can see my screen?
Yes, miss. Can hear. You can see, sorry.
Okay, thank you. Okay, so for questions 1, acceleration of A1 is 1.5 meter per second square at 30 degree. And another acceleration A2, another vector, is actually 2.6 meter per second square at 145 degree at a point. So determine by calculation the sum of the vectors and also the subtraction of the vectors. Okay, so when we first look at the requirements, so they required the sum, the vectors, and also the subtraction of the vectors. So you may think about maybe you should use the parallelogram that you learned earlier. Okay. Okay, so for your information, if let's say we have, but for these questions, we are not using the parallelogram and also the nose to tail method, okay? So the parallelogram and also the nose to tail method, these two methods, I think you have learned in your previous high school study, and is quite commonly used, especially when you want to find the addition of the vectors and so on, right? But here, that time when you use it, right, I think normally for the vectors that you learned earlier, okay, maybe in your previous high school, so your vector normally should be in this form. So for example, your vector might be in this form. Okay, most probably your vector will be, you will always present your vector in this form. So when you present your, of course, this vector will represent, this vector is representing the magnitude and also the direction. Okay, so the vector should be looks like this. Okay, so maybe here is 3, here is 2. So this can be the vector. Okay. Okay, so this can be the vector, right? Okay. However, okay, then if let's say you have your vector in this form, so I think to using some of the methods you used to use in high school, like the parallelogram and others method, then I think will be fine. Okay, but the vectors given here is not in this form. Okay. So the acceleration is given as 1.5 meter per second square, and they give you the angle. Okay, they are not giving you the vector in this form. Okay, then for A2 which is in this form. Okay, 145 degree. Okay, So we can see when come to engineering math, sometimes how they deal with the vectors compared with how you learn earlier, it might be slightly different because of the different application. Okay, so since the applications is different, the problems they deal is different. So the vectors is given in this form, then we may need to slightly change the way we solve it. Okay. Okay, so let's say I show you for number 1, okay, I'm not sure how you actually solving this, okay, so let me showing you how I solve for the first one, okay, so when come to your the vector, most of the questions we are going to solve by using the horizontal component and also the vertical component, okay, so now, let's start with the, okay, when we look at these two vectors, right? So 1.5 is at 30 degree. So let's say 30 degree is here. Okay, 30 degree. And this vector with the values of 1.5, right? Okay, then say you have another vector of 145. Okay, so let's say about here. So that means from here to here, 145. Okay, so A2. Okay, so this is another vector. Okay, so now when we are doing the A1 plus A2, right? Okay, so A1 plus A2. So what you can see right here, that means you want to get the resultant vector. So remember, resultant vector means what? Okay, resultant vector means the addition of the two vectors. Okay, addition of vectors. So now you are adding A1 and A2. So you can find the resultant vector. Okay, so let's find as usual. Okay, we start with the horizontal component. Okay, so your horizontal component, right? Okay, when we look at here, okay, start with A1. So A1, we just find A1 is actually 1.5, the acceleration. 1.5 multiply with cos 30 degree. Okay, 1.5 multiply with cos 30 degree. Then come to second acceleration is 2.6. Okay, multiply with cos. Okay, remember we follow how we do for the, you can follow the way how you do it for this one. Okay, we always measure the angle from the positive x-axis. Okay, so that means for the A2, our angle is 145, okay? So this is your horizontal component. Okay, let's calculate it before we proceed. Maybe you can give me the answer in 2 decimal places. Anyone?
Negative 0.83.
Okay, negative 0.83. Okay, after the calculation, give you negative 0.83. Okay, then come to vertical component. Remember, when come to vertical component, since we are always using the angle from the positive x-axis, so when you calculate vertical component, all the values are remain, you are just changing the cos to sine. Okay, you are just changing the cos to sine. So we have 1.5 sine 30 plus 2.6 sine 145. Okay, let's calculate for the value. Okay, so Saad gave 2.24. Yes, correct. Okay, 2.24. Okay, so now we have horizontal, we have vertical. Then the next is to get the resultant vector, the addition of the two vectors, you need to find the magnitude of A1 plus A2. Okay, so remember how we find the magnitude of A1 plus A2? So we are calculating R equals to square root of H square plus V square, right? Remember H square plus V square. So horizontal, negative 0.83 square plus 2.24 square. Okay, so let's calculate. Okay, 2.39, correct. And can you see this is about acceleration? So the magnitude you get is also acceleration. So meter per second square. Okay. Then the next is you need to find the angle, right? Okay, to find the angle. So remember when we find the angle, right? Arctangent. So once we involve arctangent, then I will tell you, we just ignore the sign first. We calculate the basic angle. So V over H, remember? Okay, for your recap. So which is 2.24 divided by 0.83. And how about the angle? The basic angle first. Okay, so we'll give you 69.67. Yes, correct. Okay, now my next question. Which quadrant is a resultant vector? Which quadrant? So how you decide, how you identify which quadrant? For the sign. Horizontal is negative, vertical is positive.
Second quadrant.
Second quadrant. Yes, correct. Okay, so it is in second quadrant. So let's find the angle for second quadrant. Okay, so that means the theta is equals to 180 degree minus 69.67. Okay, so calculate the angle. So it should be 110.33, yes. Okay, 110.33. Okay, so this is the angle. Okay, this is your, the angle is the angle for the resultant vector, A1 plus A2, and the magnitude is 2.39. So that means, okay, A1 plus A2 is 2.39 meter per second at the angle of 110.33 degree. Okay, so can you see the questions giving you the vector of A1, A2 as how many meter per second square at how many the angle? Okay, so now for the resultant vectors, you obtain as 2.39 meter per second square at the angle of 110.33. Okay, so we are calculating exactly the same form as the vectors that we have. Okay, so it should be, yeah, this is the one. Okay. I think the angle should be 110.33. Okay, Saad, so maybe you should check your answer again. Okay, get it? How we actually get this answer? Okay, so now I would like to move on to next one. Okay, so just now we have A1 plus A2, right? Then how about if we involve the second one, which is A, okay, second one, which is A1 minus A2. Okay, A1 minus A2. Okay, so now, if according to the previous diagram, okay, so when you look at here, this is actually A1 plus negative A2. Okay, so A1 is still remain. Your A1 just now, by looking at this diagram, so this is your A1. 30 degree. And this is your A2. Can you see your A2? Your A2 is with the direction of 145, but now you're having a negative. So that means it's the opposite direction. Okay, so this is negative A2. Okay, so what do you think is the angle? Okay, so can you see 180 minus 145, then here will be 35. Okay, so that means here will be 35. Okay, then this is your negative A2 with 35 degree here. Okay, okay, get it, right? Remember, the negative sign is actually giving you the opposite direction. Okay, opposite direction. Okay, so this is your A2, negative A2. Okay, so now you need to find the resultant vector for these two. Okay, so because it is the same as a plus of negative A2. Okay, so how are you going to get your answer? Okay, as I say, I suggest you to using the horizontal and vertical component, right? Let's calculating the horizontal component. Okay, so A1 is remain, so A1 is actually 1.5 cos 30. Then A2 is actually 2.6. But for negative A2 here, okay, your angle is changed already. Okay, because it's opposite direction, your angle changed already. So, but remember, as I say, if I'm using the horizontal component, I can always measure from the positive x-axis. So that means 360 minus 35, then will be 325, the angle. So cos 325. Okay, calculate for the answer. So you can use many different angles here, but then you need to adjust on the sign. So if I always follow I always measure the angle from the positive x-axis, I don't need to put in the sign. Okay, so let the cos to determine the sign. Okay, so because if we calculating according to the positive x-axis, then it will reflect on which quadrant. So when you're calculating the cos, the cos will determine the sign. Okay, so how 325 is coming? Okay, so Saad, you look at the earlier, okay, so can you see what is the vector for A2? So can you see this is a vector for A2? Okay, but now our vector is minus A2. As I say, minus with the minus sign, the vector with minus sign means the opposite direction. So this is the opposite direction. Okay, opposite direction. So when come to the opposite direction, can you see here will be just now this one, your A2 is actually 145. So if let's say 145, the basic angle is 35. So opposite direction, this is the vector A2. Then the angle here will be 35, right? 35. So if I measure from the positive x-axis until the negative A2, then will be 360 minus 35. So which is 325. Get it, Saad? Okay, so got it, huh? Okay, so now, okay, calculate for the horizontal component. .43, yes, correct. Okay, 3.43, huh? Okay. Then next one is a vertical component. So as I say, when come to vertical component, if you always measure the angle from positive x-axis, okay, then you just need to change the cos to sine, and all the angle just remain. So sine 30 degree plus 2.6 sine 325. Okay, then calculate the vertical component. Okay, Ilalam get negative 0.74. Yes, it's correct. It's a negative value. Okay, so now we have horizontal and vertical. So what is the next? We need to find the magnitude. So the magnitude of A1 minus vector A2. Okay, so the R equals to square root of 3.43 square plus negative 0.74 square. Okay, 3.35. It's not 3.35. 3.51. Yes, okay. Answer from Harold. So 3.51. Okay, then next we find the angle. So as usual, we find the basic angle first. V, which is 0.74 divided by horizontal 3.43. Find the basic angle. .17, yes, correct. Okay, then, okay, guys, so which quadrant? We have horizontal positive, vertical negative.
Fourth quadrant.
Fourth quadrant.
Fourth quadrant, yes, correct. Okay, so fourth quadrant, that means we have to calculate 360 minus 12.17. Okay, so which is 347.83 degree. Okay, so now what is the your answer for A1, vector A1 minus A2? So this is the meter per second square, and this is the angle. Okay, so we will say the answer is A1 minus A2 is 3.51 meter per second square at 347.83 degree. Okay? Okay, guys, can you understand now? Okay, so yes, okay, so can you see when we look at the diagram, this is A1, this is negative A2, and for the A1 minus A2 is actually with the angles here. So your A1 minus A2 is here. Okay, this is A1 minus A2. Okay, so the angle is actually 347.83. Okay, so that is A1 minus A2. So when come to A1 plus A2, okay, A1 plus A2, so the resultant vector should be around here. So this one is A1 plus A2 with the angle that is 110.33. Okay, hope you can understand. Okay, so this is a resultant vector for A1 plus A2. Okay. Okay, so now let's move on to the next question. Okay, number 2. Okay, so for A2, Albert walks in the direction north 20 degree, west for 25 meter, which is a vector A, and then he continues to walk in west 40 degrees south for 30 meter, okay, vector B. So now why we can take this as a vector, because there is a magnitude and also direction. When there's a magnitude and direction, that is a vector. Okay, that is a vector. So it's for this case, it's like the displacement, right? Part A, draw a vector diagram to represent the above situation, and B, determine the magnitude and direction of a line connecting his starting point to his final position. So which is the VA plus VB by calculation. Okay, let me later I will explain details about the concept for part B. Okay, so now let's look at the vector diagram to represent the above situation here. Okay, so let's draw out the two vectors here. There's a vector A and vector B. Okay, so if I present the vector A and B in the same diagram, okay, then it may look like this. Okay. Okay, so now for the first one, vector A, north 20 west, okay? So where is north 20 west? Okay, so where is second quadrant? Yes, okay. North 20 west, so second quadrant. Okay, I use different color. So that means here is 20, okay, 20 for 25 meter. So this one is 25 meter, and this is VA. Okay, VA. So next one is west 40 degree south. Which quadrant?
The third quadrant.
Third quadrant. Okay, so that means Okay. West 40 degrees south. Okay. So let's say 30 meter. Here is 40. Okay. So 30 meter, right? Okay. Then VB. Okay, so for your information, north, south, west, east. Okay, okay, so now this is a diagram, okay, for the two vectors. Okay, then continue part B. Determine the magnitude and direction of the line connecting his starting point to his final position. Okay. Okay, now, suppose when we look at the problems, right? Okay, at first, Albert is actually walk by this direction. Then he continues to walk by this direction. Okay, so if we try to reflect exactly on this one, okay, so that means first, this is a vector A, okay, 20 degree. Then after that, he followed by this direction. Okay, this direction, okay. And here is a 40 degree. Okay, so this is a VB. Okay, VB, right? Okay, so because it's followed by this direction. Okay, but just now I present on the same Venn diagram. Okay, so this is what is happened. So now they are saying that, okay, determine the magnitude and direction of the line connecting his starting point to his final position. So if I refer to this particular one, where is a starting point? The starting point is here. So after he walked 25 meters, right, he changed the direction, which is with the second vector, okay, second vector. So with 30 meters, then this is a final position, beginning, starting point, and the final position. So if I look at this one, they say a line from the starting point to the final decision. So if I'm looking at this one, this line is what? This line is a resultant of the two vectors. Okay, can you still remember the nose to tail? Nose to tail, huh? Okay, so that means for this case, right, the red line is actually VA plus VB, the vector of VA plus VB. Okay, that's what you are looking for. Okay, that's what you're looking for. Okay, so now that means you are adding two vectors lah. Basically, you are adding two vectors. Okay, so you understand, huh? So I give you a few seconds to digest this diagram. Y is VA plus VB. Anyway, the questions already tell you. So, but I'm just trying to explain to you, else you may not understand why starting point to the final position then is actually VA plus VB. Okay. Okay, so I give you a few seconds to digest this diagram. Then we return back to the question. So now you need to calculate the magnitude and direction. So basically, you just calculate as what I showed you previously, like the horizontal component, because you want to find the resultant vector. Okay, so for horizontal component, okay, maybe we can refer to this diagram, okay? So for the VA, okay, your vector is in the second quadrant, right? So you measure the angle from here to here. So 90 plus 20, which is 110 degree, okay? Then for the others one, for the second vector will be from here to here. That will be 180 plus 40, 220. Okay, So for horizontal vector, okay, for VA 25 meter. So 25 times cos the yellow angle 110, then plus the VB is 30 meter. So times cos 220, the red color. Okay, find the answer. Okay, horizontal component. Negative 31.53. Okay, yes, negative 31.53. Okay, next vertical component, 25 sine 110 plus 30 sine 220, 4.21. Okay, 4.21 correct. Okay, then next, okay, find the magnitude. Okay, magnitude. 31.81. Okay. 31.81 and direction. Find the basic angle first. Get the basic angle first. Seven point 7.61, then okay. Next, okay, which quadrant?
Second quadrant.
Second quadrant. Horizontal is negative, vertical is positive. Second quadrant. Saad? Okay, okay, Saad, can you understand why second quadrant? Negative for horizontal component and positive for vertical component. Yes, okay, second quadrant. Okay, then so we take 180 minus 31.81.
Miss is 180 minus 7.61.
Oh, yeah, sorry. I just realized. Okay. Okay, so 172.39. Okay, so this is the direction. Okay, so that means VA plus VB is 31.81 meter. Okay, at 172.39 degree. Okay. Okay, so done for the first two questions. Okay. So is that clear so far for the first two? First two is actually quite similar question. Okay, so is that fine so far? Clear? Huh? Okay, good. Next. Okay, so we continue with the questions with the tension, the static equilibrium. Okay, so let's look at number 3. Okay, so a load of 5.89 Newton is lifted by 2 strings, making an angle of 20 degree and 35 degree with the vertical. When they give you the angle, you have to be careful whether they give you with the vertical or with the horizontal. Okay, calculate the tensions in the string. So this one you may need to draw it out yourself, okay, so that you can see it clearly. So of course, if you are talking about the assessment, the drawing will not give you any point, but this is just for your own understanding and make it easier for you to solve the question. Okay, so that means now we have a load. Okay, so the load is actually 5.89 Newton. Okay, lifted by 2 strings. So let's say these are the 2 strings. So, okay, their tension, let's say this is tension 1, tension 2. Okay, 2 tensions, right? Then the angle is 20 and 35 with the vertical. Okay, so that means, so the first one is 20 degree and the second one is 35 degree. Okay, so this is the problems given. Okay, so now, okay, so for this case, right, okay, this is actually in the static equilibrium, right, okay, then, okay, so remember, if you want to find the tension, so first we will look at the horizontal. Okay, we will look at the horizontal. However, okay, I will suggest you to find the angle with horizontal. Okay, so your angle is in vertical. So find the angle measure with horizontal. Okay, because we always using cos for horizontal component. If let's say your angle is measured on horizontal, okay, so if Else, if you're using the angle for vertical, then you cannot using the cos sign that you normally use. Okay, so what is the angle here? If here is 20, that means here will be 70. Then here will be 65. Oh, sorry, 55. Okay, get it? So because previously when we measure on horizontal, right? Okay, then we always using the cos for horizontal. Okay. Now, okay, let's look at the T1. So T1 cos 70 degree is equals to T2 cos 55 degree. Okay, T1 cos 70 is equals to T2 cos 55. Okay, so this is the first equation. Okay, so let's try to get the T1. Okay, so T1 will be T2 cos 55 divided by cos 70. So let's take cos 55 divided by cos 70. Make sure your calculator is in angle. Okay, 1.68, correct? So this is 1.68 T2. Okay, 1.68 T2. Okay, then next is vertical. Okay, so we add both vertical component for T1 and T2. So for T1, it will be T1 sine 70, okay, plus T2 sine 55 equals to 5.89 Newton. Okay, this one is already in Newton, okay? So that means you don't need to multiply by include the gravity already, okay? So this is a second equation, right? Okay, so now for the T1 that you obtain here, which is this one, you substitute here, okay? So which is 1.68 T2 multiply the sine 70 plus T2 sine 55, then equals to 5.89. Okay, so let's simplify this. Okay, 1.68 times sine 70. Okay, then plus T2 sine 55. So you can simplify the left first. So when you simplify the left-hand side, 1.68 times sine 70, then plus sine 55. Okay, so the left-hand side you get 2.40 T2 equals to 5.89. So you can get your T2. Which is 2.45. Okay, 2.45 Newton. Okay, 2.45 Newton. Okay, I need the students to help me to verify. Do you get the value about 2.45? It was slightly different if you're using different decimal places. Anyone to verify my answer?
Miss, I got 2.46 Newton.
Okay, 2.46. Okay. I'm using two decimal places here. I'm not sure is it because of the decimal. If I'm using more decimal places, I may get 2.46. It should be fine.
Yes, Miss. I got the same answer.
Got the same answer, huh? Okay. Yeah, I think it's just a rounding error. Okay. If I get the answer in more decimal places, then I can get I will get 2.46. Okay, doesn't matter. You can also give 2.46. As I say, it just depends on the how many decimal places you use. Okay, then we proceed to find T1. Okay, so substitute T2 into here. Okay, so T1 equals to 1.68 times 2.45. So of course your value will be slightly different according to what you substitute. 2.45 or 2.46 might be different. So I get 4.116. Okay, if I remain as 2 decimal places will be 1, 2. 4.12 Newton. Okay, or you may get 4.13. Okay. Okay, so this is the 2 answers. Okay, T1 and T2. Okay, done. Okay, is that clear?
Yes, miss. It's clear.
Okay, so just one thing you need to take note. Okay, so when we calculating, if we always using horizontal, if we use cos to calculate for horizontal, we always using cos to calculate horizontal. That is because our angle is measured on the horizontal. So please take note. Then we calculate using cos. If let's say your angle is measured according to vertical, then you can't using cos anymore. So have to take note of that. And we are so used to horizontal, we're using cos, vertical, we're using sine. So if you want to remain on using this one, then you don't want to get yourself confused. So that means you will always stay with horizontal using cos, vertical using sine. Then you have to make sure you be careful with the angle. Okay, so be careful with the angle. The angle should be always measured on the horizontal. Okay, okay, then let's move on to question 4. Okay, so questions 4 is another question, number 4. What is the time? Oh, okay, so maybe one more question we go through. Okay, so a unicyclist at a certain point on a tight rope deflects the rope as indicated in the figure. If the total weight of the cyclist and the unicycle is 1550 Newton, determine the tension T1 and T2 in each part of the cable for him to be stable. So since it says stable means is in the static equilibrium. Okay, so I'm not sure whether you can see it clear or not. The angle here is 5.5 on the horizontal, and this one is 6.2 on the horizontal. Okay, so with the T1 and T2. Okay, here they already tell you which one T1 and T2. You have to follow exactly. Okay, don't simply change the T1 and T2. Okay, then you just do it as usual. Okay, can you please do it now? Okay, and then later I will, you can post your solution, else I will also ask someone to post a solution. Okay, I give you 5 minutes here. Let's try questions 4. The concept is the same as what we did in the slide and also the earlier question. Okay, so I give you 5 minutes. Let's do it now. So if anyone already done, you can share your solution, snap the photo of your solution and share in the chat box. Okay, yeah, I saw the solution shared by Cheng Hao. Let's have a look, okay? How about others? Do you get the same answer as the answer from Cheng Hao? T2 is 7598. Okay, the answer is 7,000 something, but I think it's different with the Cheng Hao's answer. Okay, Samuel got it as T1 as 7607 and T2 as 7599. Samuel, you get 7607. Is it 7? Because your answer very close, except the 7. Close with my answer. Yeah, 7609, okay, from Harriet. Yeah. For T, okay, but Samuel, I think you mistakenly, okay, I think your answers for T1 should be for T2. And the T2 one should be, wait, I got confused already. Yeah. Correct. My mistake. Okay, you are right. Okay. I don't think the 09 and 07 is because of the rounding. It's a bit too much of the difference. Okay, so Harold, can you share your workings, Harold? Okay, so we just wait for the solution from Harold. You use 0.999. But even you use 0.999, hold on. I think you all better check your answer. Even using 999, the answer I think won't be 07. It could be something not that much of difference. Okay, let's have a look with the answer from Jingyan. Solution. Oh, the handwriting is nice. Okay, let's have a look. Okay, so first, let's look at the okay, let's look at horizontal. So guys, you all check your solution as well. Okay, so the horizontal will be T1 cos 5.5, correct? T2 cos 6.2. Then T1 is T2 cos 6.2 divided by cos 5.5, then 0.9987, correct? Then horizontal will be vertical will be T1 sine 5.5, T2 sine 6.2, correct? Then 1550. Okay, so then substitute, correct? Okay, then try to calculate, you get 0.2037, correct? So calculating, you get T2 for 7609. Yes, correct. Then substitute for the, okay, I missed up his answer, is it? Oh, I missed up 7599.34. Okay, 7599.34. Okay, 7599.34 or 7599 also can. Okay, so correct, 7599.34. Okay, yep, the working is correct. Okay. Okay, so okay, now you use the yes.
Earlier one, I actually my answer was 9, so I wrote wrongly. So
Yeah.
my first one was 7609. But then if for the T1, if I use 0.999, the second answer, which is T1, is 7601.
Yeah, most probably it will have slight difference, but it won't come to 2. That's why just now raised my concern. Okay.
Oh, but then the second one, it did though have a difference of 2. Like if I use 0.999 multiply 7609, I get 7601.
Okay. So in the exam or assessment, we will look at what you use. Okay. If let's say answer is slightly different with my marking scheme, I will normally check again, see what you use. So I will check according to your script. Okay. Okay. Then let's okay. Questions from Wei Huan. What if I use T1 without calculating the answer of T1? Okay, hold on. Yeah, I think Cheng Hao's one is wrong because it's quite, wait, is the T2 is totally wrong already.
No, but like I calculated if 1150 divides 0.204 is this answer, and if you use 0.2037 is your answer. So it's
okay.
one use 4 decimal place, one use 3 decimal place.
Okay. Hold on. Yeah. Slightly different. Wait. 204.
I think the difference is at the 0.204 there. I think the answer is actually 0.2037. So I think that 37 changing it to 4 made the difference.
The difference is quite large, you know. The difference is quite large.
So in exam, we considered wrong if we use 0.204. Are we considered wrong or
It's
correct?
not considered wrong. It's not considered wrong. But I'm just quite surprised. It's actually quite a
Very
big
big
difference.
difference.
Oh, what a very big difference. That's why I'm calculating for a few times. Is it something? Because normally I don't encounter such a big difference. It's just 1 or 2, okay? But I don't know, when I calculating for many times and I look at the figures, yes, it's actually quite a big difference. I'm quite surprised here because it's actually not, it's already up to 3 or 4 decimal places already. So I'm quite surprised on that. Okay. Okay.
Yes.
But suppose we will follow your student's answer. If workings are everything is correct, then the figures given when you round up is, let's say 3 decimal places is also correct. Then everything is correct. Then suppose we will base on your answers. Okay. So normally not need to worry about that. But because this is a big difference, when you come to here, then it's also quite some difference. Okay, so that's why initially when I look at the question, so much of difference. So I don't think, I think it's somewhere not wrong. Okay, so I never thought of the rounding error. Yes.
I think it's because it's a large number divided by decimal places. That's why it's very big difference.
Yes. Okay, because of thousands of something. Yeah. Okay. Okay, so I think no worry. Okay, so make sure your working is correct. So normally when I see the working is correct, then I will check truth of it. Okay, then yeah, back to the questions from Wei Huan. What she means like without calculating T. Oh, okay. Okay, the way Wei Huan is calculating, he will try to how to say, reduce the rounding error. Okay, so that means she didn't make the calculate the value for T1. She just using cos 6.2, cos 5.5. Then he just substitute with this value and then calculating for T2. Okay, so by using this way, okay, then can able to reduce the rounding errors a lot lah. So yeah, I'm fine with this one. This one because the workings looks fine. At the end, we want the answer for T1 and T2. That is fine. It's okay. Okay, Wei Huan, your answer is fine. The working is fine. Okay. Okay, so Cryptacon, I think I answered the questions already, yeah? Okay?
Yeah, okay, thank you.
Okay, Wei Huan, okay? Okay, so then let's give you a short break, okay? What is our next question? Oh, the next two questions also looks a bit similar, it's the same, static equilibrium. Okay, static equilibrium. So you can try on this, okay, but I give you a short break, then we will continue 5 and 6. Okay, if you think okay, then I may not need to carry out the discussions. Let's see how much time we left. So I can just give you the answer and check. Okay. Later, if any one of you show the workings, then it's even faster. Then I just show the final answer. Okay, 10 minutes break. Okay, see you after 10 minutes. Hi students, let's continue. Let me take the attendance first. So you are today Monday T4. Okay. Today I just started another engineering maths class with your junior. Two hours. Okay, take your attendance. Where are the other three students? Who are the three? Saad? Saad, are you here? Samuel? Okay. Saad.
Yes, miss.
Okay.
I don't know why I'm trying. my AP space was locked out.
Okay. Saad? Okay. Okay, so I'm not sure Saad is around or go for a break. Okay, longer break. Now, let's move on to continue with the question. So I'm not sure whether some of you already tried the question and okay, this is a question 5 with the answer. Maybe you can check. And let me paste another one. So because if any one of you have the solution and get the correct answer, can you please share? Okay. So we have question 6. Let me share my answer for this one. Okay, there's a T1 and T2. So T1, I got it as 70.7 Newton. Or T2 is 100. Or you can correct to 71, then T2 is 100 Newton. Okay. So do you have get the same answer? Okay, number 5. Okay, anyone have a solution to share? Do you get the same answer? Check the answer first. Then can I ask for the solution? Okay, just came back, Saad. Okay, so I take your attendance. Okay, all students present. So far, the attendance is good. Okay, Cryptocon, have you done question 5.
No, man.
No, okay, I look for others. Junho, how about you? Have you done? Number 5. Junho? Ko Junho, are you here? Yes, but answer is wrong. Okay. Okay, then never mind. So let me show the solution. Okay, so this one you need to be careful with the direction because you can see the 2 arrows are going to the left. Okay, so let's see how we actually solve this question. A weight of 10,000 newtons is supported as shown in the figure. Determine the magnitudes of the forces on the members T1 and T2 for the system to be stable. So that means this one is in the static equilibrium. Okay, so here given as 1 meter and right angle 2 meters here. This is 2m. Then what is the angle? So you need to determine the angle first. Okay, so you need to determine this angle. Okay, so we need to solve for the angle first, right? Okay, so when you look at here, we have the length. If this is a theta, so we have the opposite side and also the hypotenuse. Okay, so if let's say opposite divided by hypotenuse, what is that? Tangent, sine, cos. Students?
Sine.
Okay, thank you. Sine theta will be 1 over 2. So if let's say sine theta is 1 over 2, that means the theta is 30 degree. Okay, the theta is 30 degree. So or we can put sine B is half. So the angle for B is actually, okay, or we just put B is actually 30 degree. Okay, so now B is 30 degree, then we can move on for the rest of it, okay? So let's look at the horizontal, okay? Horizontal. So can you see when come to T1, T1 is already horizontal, okay? T1 is already horizontal. So you can write as T1 cos 0. And of course, T1 cos 0 is 1. So it's also same as T1. If you write T1, it's also correct. Then T2, can you see the horizontal component also towards the left? Okay. So T2 will be cos 30 degree. Okay, T2 will be cos 30 degree. Then equals to what? Okay, can you see we have nothing else at the right hand side? Okay. So that means I put a 0, right? Okay, the left equals to the right, but the right, we don't have a right component here, right? So we put a 0 here. Okay, so that means cos 30 is actually 0. Okay, here is cos 30. Yeah? Okay, hold on. Cos 30. Okay, hold on. T1 equals to T2 cos 30. Oh, okay. I think most probably my answer is wrong already. Okay, hold on. So cos 30 is a square root of 3 over 2. 0.866 T2. Okay, I think I realized one of my mistake. Okay. So most of it, this is not the answer. Hold on. Okay, I check it out later. Okay, so this is a first step. Okay, then let's move on to the next one, the vertical. So vertical, we will have for T1, right? So then from the vertical, from T1 should be 0. Okay, so because T1 sine 0, then plus T2 sine 30. Okay, which is equals to 10,000. Okay, so this is the second one. And when you calculate this, sine 0 is also 0. Okay, this one is 0. So sine 30 is 0.5. T2 equals to 10,000. So T2 equals to 10,000 divided by 0.5, which is 20,000 Newton. Okay. Then calculating T1. So T1 equals to 0.866 times 20,000. Okay, from T2. Okay, so 17320. Okay. Okay, yeah. So this one should be the answer. Okay, I have some calculation. Okay, mistake. Okay, yeah.
Miss,
So,
the first equation, the T1 cos 0 plus T2 cos 30. When T2 cos 30 throw over, no negative.
yes. Negative, sorry. Okay. True. Transpose to the left. Right. Okay. Negative, yes. So there is a negative here. Hold on. Negative. Yeah, negative. So this one should be negative 17320. Okay. Okay, so yeah, this is my answer. So sorry, this one I put the wrong answer just now. Okay, it should be 17320. Okay, then done. So let's move on to the next one. Okay, so 3 ropes ABC are supporting a load of 100 Newton. So given theta as 45. Okay, so theta is here. So theta is here, 45 degree. So that means here is 45. Okay, here is 45. Then the system is at rest. Okay, so determine the tension in rope A and rope B. Okay, so now, okay, so for the horizontal, let's start with T1. So T1 cos 45, that is to the left, right? Then T2 to the right, okay? So T2 cos 0, exactly horizontal, okay? So which is a 1, right? So that means here I have T2, this is 1. So actually I have T2 equals to cos 45 P1. So which is 0.7071, or you can put 707, 1, then T1. Okay, so here instead of taking T1, I'm taking T2 since I have T2 already. So here, because it's a 1, 0.7071 T1. Okay, then next, continue with vertical. So for vertical, we have a T1 sine 45. plus T2 sine 0, so is a 0, equals to the load of 100 Newton. Okay, so no more T2 already, sine 0 is a 0. So T1 sine 45 is also 0 0.7071. T1 equals to 100. So T1 equals to 100 divided by 0 0.207071. So you get 141. Okay, why my answer is a bit different here? Hold on. Okay, so this part is correct. T2 sine 0.
I mean, I think you didn't sub it in.
Wait, T2 sine 0. Yeah, this one correct. T1 sine 45, correct. 100 divided by 0 0.7071. Okay, I think previously I'm using the square root, the surd, but it's supposed to be the same. Okay, so T2 will be equal to 0 0.7071 times 141.42. Okay, this one is 99.998 something. So if I rounded, the numbers is actually 100. Okay, but my T1, okay. Oh, okay. So this one I write it wrong. Yeah, the answer is correct. So this one is, I write it wrong just now. Okay. Yeah, everything is correct. Okay. Yeah. So I substitute here. Then I get T2 100, T1 as 141.42. Okay, is that okay? So it's also static equilibrium, but slightly different, the way they set the question. Okay, so done for this part of the question. Then is that okay so far for static equilibrium? Before we move on to the questions with many forces. Is that clear?
Yes, miss, it's clear.
Okay, then we move on to question 7. So this question 7 have quite a lot of the calculation. So maybe we just pick one of the question first. Okay, so basically they are the same. Okay, they are same. So it just deal with the different forces. And of course, the last one, there are 5 forces. Okay, so let's see what we need to do for the questions here. The concurrent coplanar forces are acting at the point. So as given in the diagram. So let's say I start with 7A. And let's see what are the requirements. Okay, so this is a requirement of the question. Okay, so the requirement is in the table. Write down the values of the horizontal components for all the forces and vertical components for all the forces. Then C, the total horizontal components. D, the total vertical components. And hence calculate E, the magnitude of the resultant forces. F, the direction of the resultant of the forces. Okay, so these are the requirement of the question. Okay, so let's start with the, yeah, okay, so let's have a table. Okay, it will be easier for our calculations here. Okay, so for the horizontal component, okay, so the forces that we have in Newton, we have the first one 8 Newton, second one 4 Newton, and the third is a 6 Newton. Okay, then followed by the horizontal component. Okay, then later we'll calculate the total. Okay, so for the 8 Newton, okay, so remember as I told you earlier, the easiest is always take the angle that is measured on the horizontal positive x-axis. So for 8 Newton in the first quadrant, we just take 8 times cos 30 degree and calculate the value. Then next one, for the second one, 4 is in the second quadrant. So let's calculate the angle. So from here to here, 90 plus 15. So which is 105. Okay. So 8 cos, 4 cos 105. Okay, then next one, we have the last one. So from here to here, that means 360 minus 60, so which is 300 degree. Okay, so 6 cos 300 degree. Okay, then calculate the total. Okay, so 8 times cos 30, 6.93, 4 times cos 105, negative 1.04, 6 times cos 300, so which is exactly 3. Let's total up. Okay.
8.89.
8.89, yes, correct. 8.89. Okay, so this is the total. Okay, so far we have done the horizontal and we have we got the total also, okay, horizontal component and the total. So next is the vertical. Okay, so let's continue the vertical component. Okay, so we just need to change the cos to sine. Eight sine 30, 4 sine 105, and 6 sine 300. So this one exactly 4. This one 3.86. negative 5.20. Okay, the total?
2.66.
2.66. Okay. 2.66. Okay, done. Okay, so I have done B and D as well. Okay. So next one, the magnitude of the resultant of the forces, E. Yeah? Okay, E, magnitude. So that means R equals to 8.89 squared plus 2.66 squared. Okay, 9.28 Newton, right? And next one is a direction. Let's find the arctangent vertical. 2.66 divided by 8.89. Both values also positive. So when both also positive in the first quadrant, right? This will be your angle already. Okay, the basic angle is the answer already. Okay, so the direction is 16.7, 16.65. Okay, 16.65 degree. Okay. Okay, clear? Right. Okay, so that means I also done this question. Okay, so initially you may see these questions as quite difficult, but after you get used to the way, then should be okay. Now let's say, let's try on this one. $70. Okay, so using the same table, calculate for this one. Okay, then okay, so maybe we can come up the angle first. For C, right, is 0 degree. D is 90 degree. For E, right, E is 90 plus 60. So this is 150. Okay, 150. Then A will be 180 plus 45. So this one will be 180 plus 45. 220. 225. 225. Okay. Then the last one, B. B from here to here, 360 minus 60, so should be 300 degrees. Okay. Okay, now let's move on. Okay, so the forces. We have so many. Okay. Start with the first one, C, 30. This one, kilonewton, kn. Okay, so 30, this one 20, 60, 40, and 50. Then this one, horizontal component, followed by vertical. Okay, so for horizontal, start with the 30. Okay, 30 cos 0. Okay, then followed by second one is a 20. 20 then will be 20 cos 90 degree. And the E is 60 cos 150. Then for A, 40 cos 225. And for B, the last one, 50 cos 300. Okay, let's calculate. This one will be 30. Zero. Negative 51.96. Negative 28.28. 25. Okay, let's total up. Negative 25.24. Then vertical. So this one easy, just 30 sine 0, 20 sine 90, 60 sine 150, 40 sine 225, 50 sine 300. Okay, so this one will be 0, this one will be 20, this one will be 30, negative 28.28. Negative 43.30. Okay, so total up. Negative 21.58. Okay, so then the magnitude. Okay, here find the R. So which is 33.01. Okay. Okay, then next arctangent, 21.28 to 5.24. Calculate the basic angle. Help me to verify for R. Is it the R is correct?
Yes, miss, correct.
Okay, thank you. Okay, so the basic angle is 40.13. Okay, 40.13. And okay, which quadrant? This time we have both negative value. It's quite rare to have
The
both.
third quadrant.
Third quadrant. Okay, negative, negative, correct. Okay, so third quadrant. Then we have to calculate the theta by third quadrant, 180 plus 40.13. 220.13. 13. Okay, so done. Okay. So suppose you still have another 2 questions, right? 7B and 7C. 7B and 7C. So I give you the answer. Okay, 7B and 7C. So you can check this out. Okay, so 7B, the total horizontal will be negative 6.46. Vertical is 2.41. It may be some small difference because of the rounding error. Then, okay, then the R is actually 6.89. Then the theta is 159.54. Okay, so you all try this out. So if you have any problems, you let me know tomorrow. Okay, so this one horizontal negative 51.11. So vertical is negative 6.90. Then R is 51.57. And the theta is 187.69. Okay, so try this out, and if any issue with this answer, just let me know. I can verify again tomorrow. Okay. Okay, so it's 4:30 already. We consider done the tutorial. Unless you have these problems for 7B and 7C, else tomorrow we will continue with the rest of the slides. Okay, and next Tuesday, someone singing. Okay.
Sorry.
Cryptacon is singing. Okay. Haven't finished the class. Let me finish the class first. Okay. Yep. Okay. So I think that's all. Okay, for today. Tomorrow we will continue the slides. Okay. Unless you have a problem with the tutorial, let me know. Okay. Okay. Then that's all for today. See you again tomorrow. Bye, students.
Thank you, Miss.
Yeah. Welcome. Bye bye.
Thank you, Miss.
Bye bye.
Thank you, Miss.